When we talk about the huge systems that run our online world, there's a legendary rule called the CAP theorem. But here's the thing. That rule, it's got this massive blind spot. One that secretly controls pretty much everything you do online, from scrolling your feed to checking your bank balance. And it all starts with a really simple, sometimes frustrating question. Come on, you've definitely felt this. You upload a picture, you hit refresh, and for just a split second, it's gone. Or maybe you get a notification for a comment, you click on it, and it's just not there. Well, that's not a bug. It's not a mistake. It's actually a very deliberate choice, a trade-off that engineers have to make, and it points to a deep, fundamental tension in how the internet is actually built. And here's the crazy part. The systems that we rely on every single day are in what engineers call normal operation 99.9% of the time. Everything's working just fine, the network is happy, data's flowing. It's only for this tiny, tiny fraction of a percent of the time that things actually go wrong. And that, right there, is the heart of the problem. The famous CAP theorem is like an emergency playbook. It's a fantastic guide for that disastrous 0.1% of the time when the network breaks. It tells you, okay, you have to choose, keep the service available or keep the data perfectly consistent. But it says absolutely nothing about what to do for the other 99.9% of the time. For the vast, vast majority of a system's life, engineers were basically flying blind. Well, that was the case, until a new theorem came along to fill in that massive gap. It's called PACELC. And it finally gives us the complete picture, guiding choices not just during system failures, but during everyday, normal operation. So here it is. The first part, PAC, that's just the CAP theorem we all know and love. If there's a network partition, you have to choose between availability and consistency. But the real game changer, the part that computer scientist Daniel Abadi added, is that ELC at the end. Else, meaning when everything is normal, you have a totally different choice to make. You have to pit between latency and consistency. And yeah, this is the choice that shapes almost everything you do online. It's a constant battle. Do you want speed or do you want correctness? Prioritizing latency means getting an answer back from a system like instantly. But prioritizing consistency means the system takes extra time, sometimes just milliseconds, to make absolutely sure every copy of your data everywhere in the world is perfectly in sync before it gets back to you. Let's make this real. Imagine you post a status update from New York. To guarantee consistency, the system can't just save it on one server. No. It has to send that update to its copies, its replicas. So it shoots it over to London. That takes 50 milliseconds. Then it shoots it over to Tokyo, another 50 milliseconds. Only after it gets the okay from the furthest server, 100 milliseconds later, does it finally tell you, yep, your post is live. That's over a tenth of a second of just waiting. Okay, so that 100 millisecond gap, that's what we call the consistency window. If the system had chosen latency instead, it would have told you your post was successful the instant it saved in New York. Super fast, right? But during that 100 millisecond window, your friend in Tokyo could hit refresh and see your old status because the update just hasn't gotten there yet. That's the trade-off, right there, in action. So this else choice, this battle between latency and consistency, has basically created two warring tribes in system design. Two completely different, opposing philosophies about how the internet should really work. First up, you've got the PA/EL camp. Their whole motto is fast and eventually correct. When things break, they prioritize availability, keeping the lights on. And when things are normal, they prioritize latency, giving you a blazing fast response. Systems like Cassandra and DynamoDB, which power tons of social media feeds, live here. They give you an answer now, and they just promise that the data will be correct for everyone else, eventually. And on the other side, you've got the PC/EC camp. Their motto is correctness first everywhere. It doesn't matter if the network is on fire or running perfectly, they always prioritize consistency. You are guaranteed to get the right answer, but you're going to have to wait for it. This is the world of your bank. You want them to be this way, right? They will never ever show you stale data. Okay, so now for the really cool part. We can actually take these two philosophies and use them to create a map of almost every major distributed system on the planet. And boom, here it is, the 4 quadrants of PACELC. Down here in the bottom right, you've got your PA/EL systems like Cassandra and DynamoDB, the fast crew. They're available, they're quick, but they're only eventually consistent. Then, top left, you have the PC/EC systems like MongoDB and Spanner. Always correct, but they make you wait. The other 2 boxes exist, but they're much less common. This one chart explains the fundamental DNA behind the tech you use every single day. So you might be thinking, okay, why wouldn't you just pick correctness all the time? I mean, who wants wrong data? Well, it turns out that correctness has a very real price. It costs you big time. Let's just take a look at Amazon's DynamoDB. If you use the default mode, which is eventually consistent, that's the EAL choice, reading data costs you a certain amount of money. But if you flip one little switch and demand strongly consistent reads, the EC choice, guaranteeing you get the absolute latest data, your cost instantly doubles. Literally, your cloud bill just went through the roof for the exact same number of reads. And then there's the cost to the business itself. Studies from places like Google have shown that even tiny delays just crush user engagement. A system that takes half a second to respond, which can happen with a PC/EC system, can lose 30% of its potential sales compared to a snappy PA/EL system. Speed literally makes money. So how in the world do engineers choose? Well, it boils down to a super simple framework. You just ask two questions. First, for emergencies, is getting the data wrong an absolute disaster? If you're a bank, yes, it is. You choose PC. If you're a social network, probably not. You choose PA. Okay, question 2. For normal times, are your users super sensitive to slowness? For an e-commerce store? Absolutely. You choose EL. For an internal data tool? Probably not. You choose EC. You just combine those two answers and you have your system's ideal profile. And that really brings us to the biggest takeaway of all. At the end of the day, this isn't really a tech choice. It's a business choice. A bank's entire business model is built on trust and correctness, so it has to be PC/EC. An online store's model is driven by quick impulse purchases, so it has to be PA/EL. The technology is just there to serve the needs of the business. So next time you're using an app, just stop and ask yourself, does this thing feel instant, even if it's sometimes a second or two out of date? Or does it feel a little slower, but totally rock solid and reliable? Now you know that feeling is no accident. It's a deliberate choice somewhere on the PACELC spectrum, and it's the hidden rule that runs the entire internet.